we're working. So there's your Q function. I can change it now, bud? Yes, sir. Yes, sir. Here's your cube root of x function. The domain of this function, negative infinity to positive infinity. The range is negative infinity to positive infinity. This is an odd function. This is an odd function. Notice the origin symmetry on this guy. What's up? Well, this one you can have negatives, right? So let's say we had y equals the cube root of x. Obviously, right? So let's make x like, 27. Actually, we don't even have to do that. Let's do negative 27, okay? So if I did y equals the third root of negative 27, what is the third root of negative 27? Negative 3, right? So whatever I bring out of there, even though there's nothing left, right? Because that's a 0 now. See how I can change that to be from being on the sign outside. So that's why it's an odd function. If I can change all the signs, then I'm good. Oh, thanks for asking. You can also, a quick way, Ileana, a way of telling as well by the picture alone is for the symmetry. If I could take this and I could reflect it over the, can I do this right? If I can reflect it over, I did it wrong. Flip it over the y and then flip it over the x. Fine. And I guess the same picture back. I'll make my picture for that. Then it's got that origin symmetry. So if I can do both flips, it's an odd function. I was trying to move this. There you go. There it is. Okay. We're good? Thank you. All righty. What you're looking at, this graph here, is actually a piece of, it could be either a sine curve or a cosine curve, but this is going to be some of our periodical behavior type graphs. Well, I think we'll do those second semester. But the point here is our vertical shifts. What causes our vertical shift? The K, in this case, what are they calling it? C. They're calling it C, but it doesn't matter. It's just that number outside by itself, correct? What causes our, oh, here's an example. So in this case, how many units did this get shifted up? 3. What causes our horizontal shifts? H. In this case, they're calling it C again. They're just showing you the point that it doesn't matter. It's what's happening to X that matters, okay? Thank you. So that's going to cause your side-to-side shift. Please be aware that there is a built-in negative. So if you see a negative value, you're really moving to the right. If you see a positive value, you're moving to the left, okay? Here's our shift, a horizontal shift. Which way did we go? To the right. How many units? 4. So, wop. There you go. Wop. Reflections. Reflections on X. If the negative is on the outside, that is your flip. Yes, that makes perfect sense. Across the X. Do we already have this already? Am I just wasting my time?
Yep.
Okay. So I'm just going to flip through these real quick, make sure that we're good. Hey, do I need to say anything about stretching or shrinking?
Yes.
Anything?
I already got it. All of these? Yes, all of these? Yeah, I got it.
Okay. Here's an example. Stretching. For those that want to hear the stretches. Let's say we had x was 1 right about there, negative 1, sorry, and x is 1 right about here. The x values are not going to change. What's going to change in this case is the distance. So if we had to go up 1 unit before, now we're going to have to go up 2 units versus 1 because of that stretch here. Same idea over here. If I have 1, then I'm going to go up 2 this time. Okay, so it's not the x's that are changing. So this is not a horizontal stretch, it's a vertical stretch. And what's happening is that everything's just stretching, all the x's will stay the same, but the y's will be affected by that number. Go ahead.
So it's like the slope. It's going from 1 to 2.
That's one way of looking at it, right? And that's why I like the way I see it. But what's really happening is that all of my x values, sorry,
You're gonna multiply by
all of the y values that I originally had are going to get doubled in this case. If that was a 3, all my outputs would be tripled and so forth and so forth. Right.
Do you like graph it like you do the slope with the rise and the climb?
You could do that with an absolute value, but you can't do that with a quadratic. You would just have to create a table and then see what happens to all the values. Okay? All right, cool. Horizontal stretches. Horizontal stretches. You guys remember this piece of the function? Let's put I don't know. Let's put the letter C in here. Remember I put the negative up front that did your flip on the y-axis? If there's a number in front of that, that also creates a horizontal stretch. Okay? Yep.
Wait, so if
You're making that go faster. What's up?
the x is negative, it reflects on the y. If the a is negative, it reflects on the x.
Yes. But also, same thing happens, right? If I'm doing the A, if I'm making A bigger, I'm stretching all my Y's. If I'm making X bigger, I'm stretching all my X's. What did I call this? Did I say C? Good, okay. I wasn't sure there. So let's talk about this here. What type of changes do we have in this guy? Is there a vertical stretch?
Yes.
Of 2. Is there a horizontal stretch? No. Okay. Is there a reflection of any kind? No. Is there a horizontal shift?
Yes.
Which way? How many units? Is there a vertical shift?
Yes.
Up or down? Up? Up or down? I am. Good job. You're going up 3 units. Moving on. It's right here too, right? Okay. So there's the original x squared, and here's our function with all the changes on it. Okay. Cool beans. I want to do this though. Let me do this. Oops. Stay there. I want to do this for you guys. What happened? My mouse broke. I broke my mouse. Okay, let me see if this works. Are you guys comfortable with drafting that on your own? You are?
No, I am not.
So, let's take it down a little bit, please. I always like to follow, when I'm going to graph parabolas, I like to follow the vertex. Okay? That's the lowest point or the highest point. What I'm going to first do is I'm going to write the coordinates of where the vertex now is. Because usually, it starts here at 0, 0, doesn't it? But there's a x change, correct? So which way am I going to end up at now? At 1. And where's my y at? 3. So I'm going to go 1 and then 1, 2, 3. So here's my new vertex. Okay? Here's what I do from there. In my mind, I'm visualizing this as the new 0, 0. Does that make sense? Because then I can just look at g of x equals 2x squared by itself. And I'm thinking to myself, okay, 1 unit away, if x was 1, 1 squared is 1, 1 times 2 is 2. So I'm going to go over 1 and then up how many? 2 units. And then, of course, because there is that symmetry, I've automatically got another point over there. Then I think, okay, what about 2 units away? 2 squared is 4. 4 times 2 is 8. Then I can go up way up there. And then I would just sketch from those my parabola. Did everyone see what I did with that? Okay, that's all I got for you guys today. Thank you very mucho. We got the second half of the recording, and this is not working anymore, so let me stop this. I think my machine is getting old already.